Dear students, today we are going to solve assignment number 2 of Mayer theory MTH644. Question number 1 is evaluate Lebesgue Mayer of the set x belongs to R is less than x less than 1 and x has decimal expansion not using digit 7. So the solution is we need to evaluate Lebesgue Mayer of the set given as consider we only denote consider we denote the given set as A, that is set A is equal to x belongs to R, 0 is less than x and x is less than 1 and x has decimal expansion not including 7. As we know that Lebesgue measure of a set, we mean to measure the length of the set, but in this case we know set A contains all real number between 0 and 1 where the condition is that x has decimal expansion not using 7. The back measure of a complement can be calculated as the complement of a set includes all elements which are even not in the set. So a complement consists of real numbers such as 0.7, 0.17, 0.27 etc. The decimal expansion of complement can be written as a complement into ai cross 10 to the power minus 1 where ai is equal to 7 for all I is equal to 1, 2, 3, so on. To find the measure of a complement, we consider geometric series with common difference 10 power minus 1 because the digit is scaled by 10 raised power minus 1. Okay, now we will put the value ai as 7 into 10 raised power minus 1 which can be written as 7 by 1 minus 10 raised power minus 1. So it will become 7 by 0.9 which will become 70 by 9. Since the Lebesgue measure is countably additive, so we can find measure of A by subtracting it from the complement in the interval 0 1. So Lebesgue measure of A is equal to measure 0 1 minus measure A complement, so it will become 1 minus 70 by 9 which is equal to minus 61 by 9. That will be the answer. Now the question number 2, discuss the measurability of f of x is equal to x square on minus 1 5. So we can solve this question with the help of two or three different methods. The measurability of a function referred the ability to measure or approximate it using certain mathematical tools. Measurability of a set. Measurable sets are subsets of the real number. So we say that they can be assigned a size or a measure. Here we are going to use Borel measurability. In this case, the real line of Borel set which includes interval and their unions which are commonly used class of measurable sets. So the function f of x is equal to x square defined on minus 1, 5 closed interval. We say function is continuous and therefore the Borel measure is possible. Therefore the Borel measure. What is the reason? Because all continuous function on a closed interval are Borel measurable. So this means that the pre-image of Borel measurable set for f of x will also be measurable. The function f of x is equal to x squared defined on minus 1, 1 5. So we have proved that it is Borel measurable set. This means that the pre-image of any Borel measurable sets under f of x will be measurable. The function f of x is equal to x square is indeed measurable on interval this in context of Borel measurability. इसी को हम जो है फर्दर लेबैक मेजर से भी सॉल्व कर सकते हैं. What is Lebesgue measurability? A function is Lebesgue measurable if domain can be divided into measurable sets in a way that pre-image of measurable set under the function is also measurable in the domain. So the set f of x is equal to x square on interval closed interval minus 1 5. The domain is closed interval, and we know Lebesgue measure is more generalization of measuring the size of the set, and it include both intervals whether they are open or closed. So the continuous function like f of x is equal to x square are always Lebesgue measurable on any size including minus 1 5. Since function is continuous function over the closed interval, its pre-image is possible. So we say its pre-image under any measurable set in its domain is also measurable. Further, more precisely, we say f of x is equal to x square. We can map it on any other closed interval. For example, the function is defined on minus 1. We can map it on 0 and 25. Since intervals are measurable sets, their pre-image of any interval under continuous function is measurable. So we say function f of x is equal to x square is Lebesgue measurable on interval minus 1 5. Conclusion is therefore we say that the function f of x is equal to x square is Lebesgue measurable on the interval minus 1 5. Please don't forget to subscribe the channel in order to get very early all assignments. Thank you.